Hi guys, welcome to my interview prep series videos. In this video, I'm going to be going over data structures. I'm going to be introducing basic data structures, and it's going to be pretty much high-level conceptual explanation. This is my first time using Wacom tablets, so hopefully my handwriting will start getting better and better as I use it more. So for now, you guys can be patient with my bad handwriting. So we're going to jump into the first data structure. Alright, so first of all, let's introduce the data structures that we're going to be covering in this lecture. In this lecture, we're going to be covering a few linear data structures. So what are some linear data structures? We are going to be talking about some linear data structures are linked lists, queues, stacks, and arrays. What it means is that it has linearly organized structure. So the first thing we're going to be talking about is linked list. In order to understand a linked list, we need to understand the concept of a node. So the first thing about a node is that we can think of a node as a class of its own. So the node class has two general properties. One of them is value or values, and the other one is pointer or pointers, which is a reference to the adjacent node. As you remember, we said linked list is a linear data structure. So here is where the linearity comes into play, because the pointer is always going to be pointing or referencing to an adjacent node. Node classes are created in JavaScript using an object. They are created differently in all different languages as well. So now let's talk about linked lists. So what are linked lists? Linked lists are in fact a group of nodes in a sequence. So what does each node have in a linked list? So each node contains a value and a reference to the next value. So then each node is going to have a value and then a reference to the next value. Again, the next node is going to have a value and a reference to the next value. So what are some attributes of a linked list? A linked list contains a pointer to the head node and a pointer to the tail node. So for example, we have search as a method for linked list. What does it do? It looks through the collection to find a value in the collection. It also looks to see if the value exists. Insert will add a new method to a specific location in the collection. And then we also have delete, which will delete one of the nodes, a specific one. So the way we create a linked list is we need a class to build the linked list, and then that class will have nested class, and then that class will have nested node class and properties and methods to manage its data. Linked lists are used to create other data structures, for example, stacks, queues, graphs, and hash tables. Linked lists are primarily used when we want to insert or delete in the middle of a collection. Also, when you want to split or join collections, that's when linked lists are a good data structure to use. However, if we are searching or accessing values regularly, that's not a good data structure to use. Also, when we need to randomly access a value or a node in the middle of our collection, that's also not a good use for linked lists. So the next data structure we're going to be looking at is stack. So stack is a linear data structure. So what stack does is it adds and removes elements in a last in, first out rule. So what that means is that the last element that's added to the stack is going to be the first element that's going to be removed from the stack. It's the same as having a stack of dishes. The last element that's being added to the stack of the dishes, if you have them stacked on top of each other, is going to be the first element that's going to be removed if you want to remove one dish from the stack. So if you want to look into the attributes of a stack data structure is also created using a class. So in the stack class, we need to store the data somewhere, and we store it inside a linked list or an array. Then we have a couple of methods that we can look into for stacks. The first one is push. It will add an element to the stack. Then we have a pop method. So what pop method does is it removes and returns the last element from the stack. And then we also have peek. Peek returns the last element, but it doesn't remove it from the stack. So when are the use cases of a stack data structure? It's useful when we only need the last item or element in the stack. Also when we only need to add items to the end of the stack. And also when we need to maintain the state and reverse the state of something easily. So talking about queues now. Queues are similar to stacks except that they add and remove elements using a first in, first out rule. Well, this one is similar to standing in a line for something. So if you're the first person in line, you're going to be the first person who's going to be out. So queues are also created using either a linked list or array. If you're working with a lot of data, we will prefer to use linked lists, and that's because of the time complexity of an array. If you want to remove an element from the beginning of an array, is gonna be linear, while for a linked list it's gonna be constant. So the methods for a queue are enqueue and dequeue. Enqueue adds a element to the queue, and dequeue removes and returns first element from the queue. Similar to stack, we still have the peek method for a queue, which returns the first element but does not remove it from the queue. So finally, let's look into arrays. So arrays are a continuous block of memory that are divided into equal parts. So with arrays, what I would like to cover is a useful method, and that's called reduce. Alright, so now let's look at what reduce does. So let's assume we have an array 1, 2, 3, 4. And the reduce method is a method that all arrays have. We can use it to reduce all the elements inside this array into a single value. So let's say in this example we want to reduce it into the sum of the numbers inside the array. So we want to reduce it into a number. So we say num dot reduce, and this reduce method will take in a callback function with two parameters. We can call them A and C, or accumulator and current value, and then we use an arrow function. So what happens here is that this accumulator is going to be something like a sum, and then the current value is going to be set to a new element inside this array every time this callback function is called. So this callback function is going to be called multiple times and the current value is going to be set to a new value every time that it's called. So the way that we're going to use this to return the sum is we're going to say return A plus C, and this works because every time that this callback function is going to be called, we're adding the current value, which is the next element inside this array, to the accumulator. Then we also set the initial value for the accumulator as the second argument to the reduce method. So over here we initialized A, or the accumulator, to start at 0. Alright, so that was a useful and interesting method for array that I like to introduce in this video. So lastly, I'll finish this video with an example for implementation of linked lists. So like we said before in this video, linked list is a class, and then it contains nested node classes. So the way we typically set up the linked list class in JavaScript, we would say class linked list, and then we use a constructor and then we set the head to null, and this is the typical syntax for an object, and then we set the size or the length to 0, and then if you want to add more methods to this class, we would add them over here. And then we also need the nested node class. The way we define the node class, we would again say class, oopsies. Alright, so we would say class, this class is called node. Again, we need a constructor. The input parameter to this one can be something like data, element, whatever you call it, and then this dot data equals to data, and then we also need to set next, because like we said, a node has a value and a reference pointer to the next value. So we have this dot next equals to, we set it to null for now, and that's the node class. So whenever we want to create a node inside the linked list class, we would just say new node, and we pass in a value, whatever we want, and this will create a node for us. And then the way this node would look like is going to be a node with a value and a pointer, which right now is going to be pointing to null. I will be introducing more data structures in the next video, and then next will be more examples on data structures, as I believe they are important topic. And this is the end. As always, thank you for watching, and I hope to see you guys in the next video, and happy coding.